Hello, and welcome to this Ethical Dilemma in Science. We're going to take a look at the problem of electronic waste, sometimes referred to as e-waste, and ask the question, are we burying the problem, or is there an opportunity for urban mining of precious resources? So, what is the issue with e-waste? And so we have a situation over here looking at kind of the new technology kind of coming out. We got, I don't want to pick on Apple. I'm an Apple user myself. Got an iPad, an iPhone, iWatch, or Apple Watch, whatever the thing's called. So I'm, an adopter of technology as well as many, many others. But we see the situation where a new iPhone comes out, and there's this race for many people to, get the latest model. Oftentimes, when their current model may be working, but there's a goal of having the best and brightest technology. And so, if we take a look at this, what we can see is that the amount of electricity used by a typical homeowner has increased by about 8.6% since 1972. That seems really low, but it was the statistics I found. But basically, we take a look at this in the 1970s. You're lucky if you had, a small television. And for those of you that are not quite sure what this is a record player. So, before the music would come out of your phone or your device, you would have these little round discs of vinyl that you would put down, and they would, play music for you. Over time, technologies have changed so that, and this one goes up to 2010, most of us have some type of mobile phone with at least some level of access to technology on that. We may have other devices which are present. We've got computers, we've got widescreen TVs, flat screen TVs, GPS devices within our cars. And this is through 2010, and technologies have changed in amazing ways over the last 12 years since this infographic was created. And if we take a look at it, what is the issue with generating more and more of this electronic waste? And so, at a very basic level, I'm going to take it, about as basic as you can get, taking a look at the different elements that are present. And so the elements are, if you want to think about it, the simple building blocks for everything around us. An atom is going to be a structure that represents kind of the smallest unit of an element. And they're going to make up everything around us. If we take a look at a human being like us, we're going to see that of the 118 elements, 94 of which are naturally occurring, only about 30 of them. And so what we have in purple here are the elements that are essential for humans, and then we've got a small number of these that are in green that have been suggested as being essential for human beings. And so we need, roughly about 30 elements to build a human being. And now we can't build a person, from a chemistry kit, but at least we have an idea of what is involved. If we take a look at the mobile phone over here, what we can see is that where a human being needs about 30 elements, most of your cell phones, we got an iPhone example, needs about 75. And so we can see in this diagram the various places where these elements, these atomic building blocks, are going to be involved in building the components of a phone. Now, we need to recognize that many of these elements associated with building a phone are going to be non-renewable, and many of them we don't have ready substitutes. We can't replace them with something else. And so what that means then is that many of these elements are more difficult to get. And so examples of that would be like rare earth minerals. These are going to be found in very isolated regions around the world and often at very low quantities. I guess that's what makes them rare. And they're often difficult to mine, very hard to mine. So you have to mine lots and lots of material, grind it up, and then extract it in some way. That becomes very, very difficult and in many cases has an environmental cost associated with it. In addition to that, many of the minerals, many of the elements that are used in the production of technology, in this case, taking a look at cell phones, is collected in a way that is associated with what has been described as conflict minerals. So, like the conflict diamonds, the blood diamonds that we talked about 15 or 20 years ago, these are going to be minerals that are mined in areas which are poorly regulated, poor safety concerns associated with it, usually in areas of unrest. And so there are very serious, very, very serious, both human rights and environmental rights concerns that are going on. But we're dependent on technology. How many of us can, set down our phone at the beginning of the day and not look at it again until we get home at night? We are very, very dependent, probably overly dependent on the advantages and the ease that technology gives us in being able to go through our daily lives. And so we take a look at this again, kind of looking at different articles associated with it. Over here on the left-hand side, rare earth mining in China, issues associated with both social, human rights, as well as environmental costs. And so in this case, smelting down these components into blocks of materials that can be sold on the market. Conflict minerals. This is a report from the General Accounting Office in 2020. So the General Accountability Office is an office within the U.S. government that kind of monitors things, that assesses what is going on and issues these reports. And so, taking a look at this and in this situation, what we can see is that about 50% of the minerals that are being imported is known. And of that 50%, about 2/3 of that is coming from an area where there are concerns about exploitation. The problem with this is that roughly 50% is indeterminate. And so either the companies did not report that information, or the companies were not able to determine where their materials came from. And so we are still very, very highly dependent potentially on these resources, these minerals, these elements that are coming from locations that the extraction is at a great human or environmental cost associated with it. And so if we take a look at this and the way that the United Nations and many of the other organizations describe electronic waste, it comes down into these different categories. So temperature exchange equipment, so things like your air conditioner, your refrigerator, even the heaters, but the heaters aren't as bad. But your air conditioner, your refrigerator work by passing chemicals through a system. And so, some of those cooling agents, these refrigerants, have concerns associated with it. And if they're not captured or recycled properly, they have the risk of interfering with the environment. Screens and monitors, so televisions, computer screens, things like that. Lamps, pretty much self-explanatory. Large equipment, and so these would be your washer, your dryer, your stove, things like that. Small equipments, basically anything smaller than the large equipment. So fans, can't even tell what this thing is, cameras, things like that. And then ultimately, lots and lots of IT and telecommunication equipment. So these are your mobile phones, your computers, your tablet devices. And what we can see in that as of 2019, all of these, with the exception of screens and monitors, have increased pretty dramatically in the 5 years leading up to 2019, with a large amount of waste, about 17 metric tons of small equipment, 6.7 metric tons of these screens and monitors, 13 metric tons of large equipment. So lots and lots of this waste that's been generated. If we take a look at this, and again, this is a UN report that came out in 2020, the end of 2020, taking a look at global e-waste that's been generated by year, and what we can see is that in 2019, the last year in which we have data for, there were roughly 53.6 million with an M, metric tons of electronic waste, and this is rising by about 2 metric tons per year. And so if we take a look at this, it's estimated that the value of this e-waste is roughly about 62.5 billion with a B, American dollars. And so lots of waste that's generated, but lots of economic potential in the waste if it could be collected or recycled properly. And we take a look at that. 62.5 billion is larger than the gross domestic product, the GDP, of many nations. And so, a huge problem in terms of waste and potential pollution, but potentially a huge opportunity in terms of proper recycling to be able to safely get these materials out. Now, if we take a look at the concepts of recycling, we can see that the formal recycling program, kind of structured, kind of safe, reliable recycling, only recycled in 2019 about 9.3 metric tons. So 54 million metric tons of e-waste, 9 metric tons was recycled properly. That's about 17%. And so a relatively low amount of the waste that is being generated is being recycled in a responsible way. Sadly, if we take a look at the growth rate of the recycling, the electronic waste is being generated at an increase of about 2 metric tons per year. Over the previous year, the growth rate of recycling is about 0.4 metric tons per year. And so we are generating more waste faster than we are developing ways to deal with the waste in a responsible manner. And so this is going to become a continuing and growing problem that needs to be addressed. If we take a look at this, and again, this is from that same EWaste Monitor report from 2020, what we can see is that different areas of the world are going to be better at doing recycling. And so we'll look at the difference between the Americas and Europe later on. But Europe is capable of doing about 42.5% of responsible recycling of their electronic waste, where within the Americas we're a little bit less than 10%. Other regions of the globe, Africa is about 1%, but they're also generating a much, much lower amount of e-waste than the rest of the world. But overall, both Asia and Oceania, kind of Australia, the Polynesian Islands, New Zealand, areas like that, are in that range of about 10% as well. And so there's great opportunity. If we take a look at this, and this is a 2014 article from The Guardian, kind of taking a look at kind of what's inside, and we're focusing in on technology, focusing in on like a mobile phone. There are a lot of things that are available in terms of the good. What we can find in cell phones is gold, copper, platinum, palladium, lithium, cobalt, all very valuable substances. According to the United States Environmental Protection Association, 1 metric ton of circuit boards, so a circuit board kind of looking something like these, basically contains about 400 to 800 times the amount of gold that you'd find in a metric ton of ore. And so you think about that. If you could mine this concept of urban mining, a metric ton of circuit boards, you're going to be able to get 40 times at a minimum. And other statistics have shown it's usually about 100 times, about 100 times the amount of gold as you would get by digging up and mining for gold, pulling it out of ore. In terms of copper, it's estimated that there are 30 to 40 times the amount of copper in a metric ton of circuit boards than what you'd get from a metric ton of ore that contained copper within it. So lots and lots of opportunity for recycling of these materials. And it's going to be a growing problem. It's going to be something that we need to address at some point because other statistics are showing, and this is in a United Nations Environmental Protection report, that estimates now that 7% of the world's amount of gold is now trapped within e-waste. And so, just do the math. 7%, if we, generate the same amount of e-waste over an extended period of time, that is going to continue to accumulate. And we're going to end up in a situation where many of these elements, many of these valuable things that we need are going to be trapped in electronic waste and are not going to be able to be mined out in the environment. Being mined, going out and mining a mine, they're not going to be available. And so another estimate says that it's about 13 times more expensive to do the mining process than to extract these elements, these important materials, from the current electronic waste. So lots and lots of potential, lots and lots of economic value associated with it, the good components over here. But again, it's not without risk. It's not without problems associated. Your cell phone also includes the bad and the ugly. It includes lead, which we've talked about previously as being a toxin and a neurotoxin and causes developmental problems. Mercury, which is very, very toxic. Cadmium, beryllium, PVC plastics, brominated flame retardants. Nasty chemicals, nasty elements that have an important role in the functioning of your technology, in the functioning of your cell phone. But it's something that you don't want to get exposed to, and so because of that, while there is great opportunities with recycling of these circuit boards and e-waste, it needs to be done in a way that is responsible, or we're going to be dealing with the bad and the ugly over here. And so if we take a look at this, there are basically two approaches to this concept of e-waste or electronic waste recycling. The first are formal e-waste recycling programs, and so this is illustrated over here in the CNN article. Actually, I think this was a CNN video looking at a recycling e-waste region in Dubai. What you can see is basically kind of a structured, highly regulated system that has health and safety rules in place. They have pollution and control technology in there. It's safe, relatively safe, pretty effective, but it tends to be a little bit expensive. But again, as we talked about on that previous slide, still less expensive than going out and mining for raw ore. And so if you can see this in a situation where you've got this formal e-waste recycling program, they're going through and responsibly disassembling the electronic components, pull out the circuit boards and have a pile of circuit boards, pull out a pile of wires and have a pile of wires. You separate them, you categorize them, you clean them up, and you process them in some way. And so if we take a look at this, again, in a regulated program with health and safety and pollution controls, you can see he's got, the safety vest on, he's wearing a mask, ideally wearing goggles. This is, again, probably 2021, so wearing a mask potentially because of COVID. But again, oftentimes when they're exposed to these chemicals, they're going to be wearing personal protection equipment, respirators, things like that. They're wearing gloves, and so you can see that it, is a ideally relatively safe environment. Now, in contrast, over here, World Health Organization report on child health associated with e-waste. These informal e-waste recycling programs, they don't have the safety regulations. They don't have the pollution control safety procedures in place. And so what you can see is that these individuals here, they're basically kind of burning through the e-waste to leave the metals behind. But in doing so, they're getting exposed to the bad and the ugly, the materials that we talked about on that previous slide. They're being exposed to toxic chemicals like lead and mercury. And it's estimated that there is a number of people that are involved with this. An estimated 12.9 million women are working in e-waste. Oftentimes in these informal e-waste programs, they're going to be using children because the children have smaller hands, they're more dexterous, they're able to go in and, because they're more dexterous, be able to work with these small components much more easily. And then again, because we've got this, kind of open burn in this trash pit, there's a huge risk for runoff of contaminants into the water and into the soil. It's estimated that workers in these informal settings are exposed to over 1,000 harmful substances in the process of trying to go through and pull out or recycle what's valuable from this. According to the World Health Organization, a child in Ghana who eats one chicken egg in close proximity to one of these waste sites is going to absorb 220 times. So 220 times the European Food Safety Authority's daily limit for chlorinated dioxins, which is a nasty chemical. So ideally, you want to minimize your exposure to it. But a single egg is going to have over 200 times the amount of this chemical present. And so that's just one example of how toxic these materials are and the risk associated with these informal electronic waste programs. And so I said we're going to look at what's going on with the United States in comparison to the European Union. European Union is approaching 50% recycling of electronic waste, where the United States is probably in the range of about 10%. Within the European Union, they've got the European Union's restriction of hazardous substances directive. And this basically is a program that is in place across the entire European Union, so all of the countries associated with the European Union, in which they are intentionally putting regulations in place for these formal recycling programs, for making sure that this recycling of materials is done in a way that is safe to the individuals doing it as well as safe to environment. And they've implemented a whole variety of programs, including requiring manufacturers to help pay for the cost of recycling. And they're also adopters of the Basel Convention. So the Basel Convention basically says that these richer countries, the first world countries, can't export their electronic waste to be dumped in other regions of the world. Now, if we take a look at the United States, there's no federal law, so that even though there are 28 states plus the District of Columbia that have electronic recycling laws, they tend to be much more limited, and because they are limited, they don't have the ability, the kind of volume to be able to build these very strong, kind of cost-efficient programs. One example of a state law is the New York State Electronic Equipment Recycling and Reuse Act, which basically says that the manufacturer of an electronic device, so the manufacturer of like your cell phone, has to provide a free and convenient recycling of the electronic waste. And so they basically have to take it back and recycle it in a responsible manner. Now, the United States has signed the 1990 Basel Convention, but this treaty is not ratified or implemented, and so we don't have to follow the guidelines. However, we are still part of an Organization for Economic Cooperation and Development agreement, which basically regulates the movement of these electronic waste between other OECD countries. And so if we take a look at what this means from a standpoint of various types of technology that many of us are using, and again, because I'm focusing in on technology in general and cell phone or mobile phones specifically, taking a look at three popular mobile phone manufacturers, we've got both Samsung, the Samsung, Google, and the iPhone that are implementing programs so that they are using recycled materials. And so basically, instead of buying raw materials that are mined from raw ore, kind of in the traditional process, they're moving towards obtaining these important elements, these important components for their cell phones in recycled. So they're promoting this responsible formal recycling, and so that we are not continually pulling resources out of the environment and dealing with the environmental concerns associated with that. Now, what this does is contribute to what has been referred to as a circular economy. This idea that there is going to be some value associated with the electronic devices after they've gone through their useful period. And so the idea is that, if you, purchase one of your devices, whether it's a cell phone or a computer, you're going to utilize it for a period of time. And then once that period of time has been used, it is going to go into a responsible recycling program. But within this responsible formal recycling program, this still has value. And so you can see, potential buyback of electronic devices, potential buyback of these cell phones and computers. So they have value associated with it. And so they're not, hibernating in the back of your desk. They're not, getting thrown out in the normal trash and being lost in landfills. They're being responsibly recycled, and in that point, they are potentially being refurbished. And so some of the responsible recycling is, during doing the urban mining, so pulling out all of the gold and the copper and all of those minerals for reuse. Other times they're actually, kind of using some of the cell phone components, using some of the technological components and retrofitting them into devices. And those devices then would have a value that would be sold, marketed and sold, and purchased again by somebody else. And so all within this, you don't see kind of a diversion of these electronic devices into landfills. You don't see them being disposed of. You're seeing that they have continual value, and because of that, they are going to be continually remaining in this rather than going back and pulling resources from, kind of traditional mining out of the ground. So this gives rise to our ethical dilemma in science for this topic is how do you increase responsible e-waste disposal and recycling? And so we've seen a couple different examples of this. The New York State model, which requires manufacturers to provide free and convenient recycling. There have been other arguments that we should really implement the circular economy program. And so one idea with that is that instead of us, we take our cell phone, we use it for a period of time, and then we either dispose of it or shove it into a desk drawer and forget about it because we own it. We have the opportunity to do that. We don't have to turn it in. We don't have to recycle it. It can go wherever. But if instead of buying our cell phone, we were to lease our cell phone, we would have to return it at the end of our contract, or if we wanted an upgrade. And in that way, it ensures, again, because the manufacturer, if we have, in my case, I've got an iPhone, if we take that back to the Apple Store, that Apple Store is going to responsibly recycle that within a formal program. And we take a look at that. Apple and many of these manufacturers, it's just because I'm an Apple user, I'm familiar with that. Apple will give you gift cards. They will take items back and use that to trade in towards the purchase of a new device. Even if it's something that doesn't have value associated with it, they will still take it and put it into their responsible formal recycling program. If you take a look at it, and I pulled a lot of like flyers, and none of them look the way I wanted, so I'm not including them here. But many politicians, many like townships or cities, will put together an e-waste collection program. Where they'll say, bring your electronic waste so that it's not going into the landfills. And so they will take many, many devices, but in some cases, some of the larger TVs, larger monitors, things like that, you have to pay for the proper e-waste disposal. Should there be a program to purchase old devices? They have some value associated with it. And so should there be an incentive to reduce the temptation to hoard them, in the back of your desk drawer, or, they have no value. I could probably recycle it, but, it's just much easier to just lob it in the trash someplace. So how is it that we are going to increase the responsible e-waste disposal? And hopefully the disposal is going to go into a formal, safe, and effective recycling program. As always, I'm going to be posting some links below with some of the additional readings or references that I thought were especially important if you're interested in reading up and getting more information about this. So thank you. Hopefully you enjoyed this ethical dilemma in science. Think about what you're doing with your electronic waste. There's a lot of value associated with it, and if we continue not disposing of it properly and recycling it, at some point in the future, we may run out of these very important minerals and elements that are needed for the technology of today. And we can only imagine the needs for these things for the technology in the future. So thank you and have a great day.